Hello and welcome to another episode of Geography Made Easy. In these videos, we try to make difficult geographical topics easy. Today we will be discussing about the Earth's interior. This will be the first video, and today I will be only talking about the layers of the Earth, and I will not go into the details of how these layers have been discovered. That will be for another video. In the year 1864, a very interesting book was published. This book was called A Journey to the Center of the Earth. This is the year 1864, which is the 19th century, the end of the 19th century, and knowledge about the center of the Earth was still, or about the interior of the Earth was still something which was being discovered. People didn't know much. So Jules Verne, he could actually write a very interesting book about a group of scientists encountering different kinds of prehistoric animals inside the earth, lava flows and things like that. There was some understanding of what the earth might have been inside, but mostly it was unknown. The situation has, of course, enormously changed nowadays, and we know a lot more about the interior of the earth. How we know about the interior of the earth, we will discuss that. So, we cannot directly access the interior part of the earth. There is no direct access. Rather, we have to look at indirect evidences, and it's very important that we understand what are these indirect evidences. And in this chapter, I will not talk about in details about the indirect evidences, rather, I will just go through them. But in the next video, we will try and look at them in details. So, because with the advancement of technology, we know that there are mines and boreholes which go deep down. And recently, very currently, the Chinese government is also wanting to create a borehole which goes really up to, it's very deep. It's more than 11 kilometers deep. But we know that the interior of the earth, the core, that is inaccessible because we still do not have that technology to access that part, and there is fear that if we do access the interior of the earth, we make boreholes, it might create instability on the earth's surface and it might create some other problems. So these are what scientists fear. So of course there is some amount of restriction as to the amount of excavations that need to be done in this regard as well. But let us look at what the indirect evidences are there which tells us about the Earth's interior. So, firstly, the first indirect evidence which we have here which tells us about the Earth's interior is the density studies, which is how dense or how closely packed is the rocks which are present on the surface or below the surface of the earth. And by calculating these, we can understand that the density changes as we go down, and from this we can understand that there are different layers having different densities inside the earth, which tells us about the layered feature of the interior of the earth. The second indirect evidence is meteorites. So meteorites are small fragments of meteors which when they enter the earth they are called meteorites. So before they enter the earth they are called meteors. Now these meteors are revolving parts of planets or stars or stardust, and many of them are part of the solar system or have been formed when solar system was being formed. So once upon a time people believe that they were part of the same planetary dust material. Now, these meteorites, if we dissect through the meteorite, as we can see here in this diagram, we can see that they have different layers. So, the meteorite, which is a lot like our planet, which is how we can understand these are cooled down extraterrestrial evidences which come into the earth, and if you're dissecting and looking at a layered structure, we can understand that the interior of the earth will or might or is also layered. And the third and the most important, this is the most important evidence, is the seismic studies, which is studying earthquake waves. And this I will discuss in details in the next video, because I have to explain a lot about seismology, seismic graphs, and the different kinds of waves which actually help us to understand about the Earth's interior. So now let us look at the composition of the earth. So what are the layers of the earth? And this is a very simplified diagram minus any other kind of terminologies I have used. So the topmost layer is called the crust, and in some books and in some different ways of defining the layers, it is called the lithosphere. So if you see the lithosphere, you will know that we are talking about what we know as the crust. Between the crust and the mantle, so basically we have three major layers. We have the crust, the mantle, and the core. So right at the center, this is the core. Then we have the intermediate part, which is the mantle, and then finally we have the crust layers. Now these, again, the mantle is divided into two layers, upper mantle and lower mantle, and the core is again divided into two layers, inner core and outer core. And we have crust, and the crust or the lithosphere is divided into two categories, mostly oceanic crust and continental crust. So we have the Sial and the Sima, which is basically talking about the composition of the material. So the lithosphere is composed of basically silicon. So silicon is very commonly seen in most of the rocks, and sand is silicon grains. So when silicon and aluminium, which is a lighter material, so we see that the composition of the crust, of the lithospheric crust, of the crust which is mostly continental in nature, is lighter or less denser compared to Sima, which is more heavier, which has magnesium. So Ma is for magnesium, and Si is of course silicon, as I have already mentioned, and Al was for aluminium. So in this way we can divide our layers of the crust, and we have two different layers of the mantle. Now between the different layers, I was talking about the lithosphere. So there is a layer which is called usually the upper mantle. It is having a plastic like feature. It is something like, it's not liquid, neither is it solid. So the crust is considered more or less solid, but the mantle is not solid. It is something, it is having the plastic properties. So from plastic, it has a plasticity or it has a elasticity, right? So this layer with the plastic or elastic property is called the asthenosphere. Now the asthenosphere is over which the crust or the lithosphere is lying. So a lot of the plate movements are associated with the asthenosphere. Let me also talk about this fact that the asthenosphere behaves like a solid. So it can be compared to, a very good example is the toothpaste. So the toothpaste inside a toothpaste tube exactly is like the asthenosphere. So the property of the asthenosphere, the consistency is like toothpaste, and when you are kind of taking it out of the toothpaste tube, it is liquidy. It is having more fluid property. But when together inside the tube, it is behaving like a solid. Or you can also compare this with arrowroot or any other kind of substance which behaves like like a liquid when we mix it in water, but actually if you keep it for some time it behaves more like a solid. So asthenosphere has a property which is similar to that. Now we see that between these layers, between the lithosphere, asthenosphere, or the mantle and the core, there is a layer which is called a discontinuity. So we can see this term here. Discontinuity is a layer which demarcates that there has been a change in the density of one layer to the other. And details of how these discontinuities were discussed, we will discuss this when we talk about seismicity in the other video. So we have two types of discontinuity here. We have the Moho discontinuity, which is demarcating the layers between the crust and the mantle, and we have the Gutenberg discontinuity, which is between the core and the mantle. So I have to remember that there are basically two major discontinuities which are there. So we have the crust and the mantle. So asthenosphere and lithosphere, there is this Moho's discontinuity discovered by a scientist called Moho who first observed this, and a scientist called Gutenberg, he discovered about this discontinuity between the lower mantle and the outer core, between the core and the mantle. So let us talk about the different layers. So we have the crust, and the crust is divided into two parts. Is we have the continental crust and we have the oceanic crust, and I already talked about Sial and Sima. So the oceanic crust is the average um, depth of the oceanic crust is around 5 to 30 kilometers, and on the other hand the continental crust, the average depth is around 50 to 100 kilometers. So the continental crust is more thicker than the oceanic crust, and the density in this case is much less than the other layers. It is around 2.7 gram per cubic meter. So this is the average density, so it is much less than compared to the other layers. And temperature is around at the surface, of course it is variable depending on which part of the earth, but as we go down towards the mantle it is around 200 degrees Celsius to 400 degrees Celsius. Next we have the mantle. The mantle is around 2900 kilometer in thickness, and now it is again divided into many other layers. There are some scientists believe it is divided into 4 layers, some scientists believe it is divided into 2 layers, and the temperature is around 2000 degrees Celsius to 4000 degrees Celsius. So it's very hot, of course. The mantle provides us with the lava. Like the magma is generated from the mantle, and when it comes to the surface, it is called lava. And the density is 2.9 to 3.3 gram per cubic meter. So yes, at parts it is much more dense, especially as we go down. It is denser compared to the crust. And finally, we have the core. The core has it has 2 layers, the outer and the inner core. And we have basically domination of iron in the core. So it is called knife, nickel, and iron. And the presence of the iron actually gives earth the magnetic property which it has. So earth behaves as a magnet because of its magnetic core, and it is very dense. It is above 9, so 9.9, nearly 10 gram per cubic meter is the density of this, and it can go up to 14.2, and the depth goes up from 2900 26378 kilometers. So 6,000, above 6,000 kilometer its depth is. So this is the average understanding of the layers of the earth, and with the advancement of seismicity, the different kinds of understanding about the interior of the earth has become better. So in the next video, when I talk about seismicity in details, I will discuss this in more details in that video. So in the meantime, if you have any doubts and questions, please feel free to comment in the chat section. And if you like this video, do not forget to share and subscribe, and please press the bell icon for notification about my new videos. So thank you for watching, and see you in the next video.